Question 2. A small particle hanging on the end of a light inextensible string, 2 meters long, is projected horizontally from the point C. We want to calculate the least speed of projection needed to ensure that the particle reaches the point D, which is vertically above the point C. So this particle is given an initial horizontal velocity of magnitude u. So that means at C it's going to have kinetic energy only. Now if we move around to any point B, the energy at C is going to equal the energy at B. Now at C it's got kinetic energy only, at B it's going to have both potential and kinetic energy. So we need to find the height B is above the point C. So we know that the distance from O to B is 2. If we call this vertical angle theta, that means this vertical height is 2 cos theta. The total distance from O to C is 2. That means this remaining distance would be 2 minus 2 cos theta. So as we said, the energy at C equals the energy at B. At C we've got kinetic energy only, so we can let that be a half mu squared, and at B we've got both potential energy and kinetic energy. So this means a half mu squared is going to equal mg times the height at B is 2 minus 2 cos theta plus a half mv squared. The m's will cancel everywhere, and if you multiply across by 2, you get u squared equals 4g minus 4g cos theta plus v squared. And if we get v squared on its own, v squared then equals u squared minus 4g plus 4g cos theta. So we can label this as equation number 1. Next of all, we're going to examine the forces on the particle when it's in position B. So the two forces are the weight and the tension. Now we need to split up the weight into parallel and perpendicular components. And if this is an angle theta, this is an angle theta also. So if this is mg, this component would be mg cos theta. So the resultant force towards the centre would be T minus mg cos theta. Now the centripetal force Fc equals mv squared over r. So the resultant force towards the centre is T minus mg cos theta, and that's going to equal mv squared over r. Now we do know that the radius is 2, so this means T minus mg cos theta is mv squared over 2. What we're now going to do is sub equation number 2 into equation number 1. So we're just going to replace this v squared with u squared minus 4g plus 4g cos theta. And if we bring the and multiply in by the m and divide by the 2, T minus mg cos theta is mu squared over 2 minus 2mg plus 2mg cos theta. And if you bring this term over, this will become 3mg cos theta. So the tension T then is mu squared over 2 minus 2mg plus 3mg cos theta. Now if the particle just reaches the point D, the minimum value of u would occur when the tension is when the value of T is 0, there's no tension, and the angle theta is 180 degrees. So at the point D, theta is 180 and the tension T equals 0. So if we substitute in 0 for T and 180 for theta, we get 0 equals mu squared over 2 minus 5mg. And multiplying across by 2 and the m's cancel, you get 0 equals u squared minus 10g, and this means then the initial velocity u is root 10g meters per second. If the speed of projection is 7 meters per second, find the angle that the string makes with the vertical when it does go slack. Now again, we've got T equals mu squared over 2 minus 2mg plus 3mg cos theta. So if the string goes slack, the tension T is 0 and u equals 7. So we substitute in T is 0 and u is 7. Now the m's will cancel everywhere. And then this means that 49 over 2 minus 2g plus 3g cos of theta equals 0. And this means then if we substitute in 9.8 for g, 7 squared is 49 divided by 2 is 24.5. And then we've got minus 19.6 plus, and 3 times 9.8 gives 29.4 cos of theta. Okay, and solving this equation, then this means the cos of theta equals minus 1 over 6. This means the angle theta then is inverse cos of minus 1 over 6, and that works out as 99.59 degrees.